In this video, I will walk you through some multiple choice questions from AP Calculus Unit 9, which is about slope fields and differential equations. Number 1. This is a slope field for which of these differential equations? Let's consider each option one at a time. For option A, dy dx is only a function of x. Think about what value of x would cause this to equal 0. When x equals -1, dy dx is equal to 0. So the slope field for this differential equation should have all horizontal slopes at x equals -1. And that is not what we see, so we can eliminate this as the answer. Look at option B. Notice that x squared is always positive, so a slope field for this differential equation should have all positive slopes. They should all be increasing, uphill, and that is not what we see. So we can eliminate option B as the answer. Look at option C. What would it take to make this expression equal 0? Well, if x and y were opposites, they would cancel each other out and make 0. In other words, if y would equal -x, then these would cancel each other out and make 0. So we should see horizontal segments of 0 slope all along the line y equals -x. And that is exactly what we see. So option C is a possibility. Look at option D. What would it take to make this expression equal 0? A fraction will equal 0 when the numerator is equal to 0, other than when y is also equal to 0, because 0 over 0 is the indeterminate form. This differential equation should have horizontal segments of slope 0 whenever x is equal to 0. So let's look at x equals 0. Do we see a bunch of horizontal segments? No. So we can eliminate choice D as the correct answer. You also could have eliminated option D by asking yourself when this expression will be undefined. This will be undefined when y is equal to 0. Again, other than 0 over 0. So at y equals 0, we should see a bunch of vertical segments indicating an undefined slope. So looking across where y is equal to 0, we don't see a bunch of vertical segments. So D could not be the answer. Looking at option E, we know that natural log is undefined at 0 or at any negative value. So a slope field for this differential equation, for values of y that are 0 or less, we should expect to see either vertical lines or maybe nothing at all. But we see a bunch of regular slopes of varying types. So E cannot be the answer. Here's another way to think about it. Ask yourself when natural log y would have a value of 0. When y equals 1, dy dx will equal natural log 1, which we know to be 0. So the slope field for this differential equation would have horizontal segments of slope 0 whenever y equals 1. So y equals 1 through this area of the graph, and we do not see a bunch of horizontal segments. So again, E could not be the answer. So the answer is C. Problem number 2. If f prime of x equals -f of x and f at 1 equals 1, then f of x equals which of these? We can eliminate most of the choices using this part of the setup. F at 1 must equal 1. If we plug in 1 for x right here, we get -2 times 1 plus 2. That's -2 plus 2, which equals 0. So we have e to the 0 power, which is 1. But we still have the 1/2 in the front. So we end up with a value of 1/2. So f at 1 does not equal 1, so we can eliminate A as an option. Looking at option B, f at 1 would give us e to the negative 1 minus 1 power. But this would be e to the negative 2 power, which does not equal 1. So this is eliminated. Looking at option C, if x is 1, we have e to the 1 minus 1, which is e to the 0, which does equal 1. So C is a possibility. When we look at D, if we let x equal 1, we have e to the negative 1 power. That's just 1 over e. That does not equal 1. So D cannot be the answer. When we look at E, if x is 1, we have negative e to the 1 power. That's just negative e. This does not equal 1. So E cannot be the answer. So based on that alone, we know that the answer is C. I want to go back and solve this the long way. Notice we didn't use the fact that f prime of x is equal to negative f of x. If they had given us more than one option that satisfied f at 1 equals 1, then we would have needed to go further. So I do want to show you how to do that so you can be prepared if you run into a problem like that on the AP exam. Let's rewrite this differential equation in a form that we can more easily manipulate algebraically. F prime is the same as dy dx. And f of x is just like y, so negative y. This is a separable differential equation. Let's get all of the y's on the left and the x's on the right. We can begin by moving dx to the right-hand side by multiplying both sides by dx. So we have the x's on the right. I want all of the y's on the left. I can move this y over to the left by dividing both sides by y. Now that I have the y's on the left and the x's on the right, I can integrate both sides of the equation. The antiderivative of 1 over y is the natural log of the absolute value of y plus c, but I'll save the plus c for the right-hand side of the equation. The antiderivative of negative 1 is negative x, and there's your plus c. Let's use this initial condition to help us find the value of c. When x is equal to 1, y also equals 1. So let's substitute 1 in for x and y. This gives us the natural log of 1 is equal to negative 1 plus c. But the natural log of 1 we know to be 0. So we have this. Adding 1 to both sides, we find out that c is equal to 1. Let's substitute 1 in for c right here. That gives us the natural log of the absolute value of y is equal to negative x plus 1. We need to get f of x equals. In other words, we need to get y by itself. We can get rid of the natural log by putting a base e on both sides. In other words, we are exponentiating both sides of this equation. Natural log and base e are inverse functions which cancel each other out. So that will leave us with the absolute value of y on the left. So now we have this. When the variable you are solving for is inside of the absolute value, you can take it out as long as you make the other side plus or minus. So we have plus or minus e to the negative x plus 1 power. Only one of these is the right answer. So we can use the initial condition f at 1 is equal to 1 to decide which one is correct. When x is 1, y should equal 1. So let's play around with that. Let's put 1 is equal to plus or minus e to the negative 1 power plus 1. This would make 1 is equal to plus or minus e to the 0 power. So 1 is equal to plus or minus 1. Obviously, on the left side, we have a positive 1. So on the right-hand side, we need a positive 1. This tells us that the positive version is the correct one. If we compare this to the answer choices, we see that option C is a match because this is the same as y equals e to the 1 minus x power. Kabam! So yeah, that was the long way to solve this particular problem, but you may need those skills depending on how the question is set up. Number 3, if dy dx equals 2y squared and y equals negative 1 when x equals 1, then when x equals 2, y equals which of these? Let's start by solving this separable differential equation. We need to get all of the y's on the left and all of the x's on the right. We can begin by moving dx over to the right by multiplying both sides by dx. Now I have the x's on the right. I need all of the y's on the left. I can move y squared over to the left by dividing both sides by y squared. Now we have this. Let's think of 1 over y squared as y to the negative 2 power. Now that I have the y's on the left and the x's on the right, I can integrate both sides of the equation. The antiderivative of y to the negative 2 power is going to be y to the negative 1 with a negative in front, and I would normally say plus c. But I will save that for the right-hand side. The antiderivative of 2 is 2x, and there's your plus c. Y to the negative 1 power is the same thing as negative 1 over y. So we have this. Let's use the initial condition y equals negative 1 when x equals 1 to find the value of c. So we have negative 1 over negative 1 is equal to 2 times 1 plus c. But this gives 1 equals 2 plus c, so c is equal to negative 1. Let's put this back in for c. So now we have this, but the question is, what does y equal when x is equal to 2? But that gives us negative 1 over y is equal to 2 times 2 minus 1. But this means negative 1 over y equals 3. Taking the reciprocal of both sides, we have negative y is equal to 1/3. Dividing both sides by negative 1, we have y equals negative 1/3. So the answer is B. Number 4, if dy dx equals y times secant squared x and y equals 5 when x equals 0, then y equals which of these? This is a separable differential equation. So let's begin to solve by getting all of the y's on the left and all of the x's on the right. We can move the dx over to the right by multiplying both sides of the equation by dx. Now the x's are on the right. We need the y's on the left. We can move y over to the left by dividing both sides by y. Now that we have the y's on the left and the x's on the right, we can take the integral of both sides of the equation. The antiderivative of 1 over y is natural log of the absolute value of y plus c, but I will save the plus c for the other side. The antiderivative of secant squared is tangent, because the derivative of tangent is secant squared. And don't forget the plus c. Let's use these initial conditions to find the value of c. Substituting 0 for x and 5 for y, we have the natural log of 5 is equal to the tangent of 0 plus c. We don't need the absolute value because we know that 5 is strictly positive. The tangent of 0 is 0, so c equals natural log 5. Substituting natural log 5 in for c right here, we get natural log of the absolute value of y is equal to the tangent of x plus the natural log of 5. We need to solve this equation for y. We need to get y by itself. So let's exponentiate both sides of the equation. In other words, let's drop a base e on both sides. Base e and natural log are inverse functions, so these will cancel each other out and leave behind the absolute value of y. On the right-hand side, I'm going to use a property of exponents that says e to the a plus b is the same as e to the a times e to the b. So e to the tangent x plus natural log 5 is the same thing as e to the tangent x times e to the natural log 5. I did this so I could simplify the base e with the natural log. These cancel each other out, leaving 5. So now I have the absolute value of y is equal to 5 times e to the tangent x. When solving for a variable inside of the absolute value, you can bring it out, but the solution will then be positive or negative. However, only one of these is the correct answer. We can use the initial conditions to figure out whether the solution should be plus or minus. When x is 0, y should be positive 5. This part of the expression is always positive because e to the something is always positive. So if the result is to be a positive 5, that will only happen with the plus version of the solution. So this is the correct answer, and the answer is C. Problem 5 is considered calculator active, so we will use our graphing calculator as needed. Population y grows according to the equation dy dt equals ky, where k is a constant and t is measured in years. If the population doubles every 10 years, then the value of k is which of these? I could solve this as a separable differential equation. However, this occurs often enough that I want you to memorize the following shortcut. When dy dt equals k times y, the solution is y equals d times e to the kt power, where d is a constant. Let's make two hypothetical initial conditions that satisfy the statement that the population doubles every 10 years. So, for example, imagine that at time t equals 0, the population is 1 person. In 10 years, the time will now be 10, and the population will now be 2, because the population doubles in 10 years. Let's use these two hypothetical initial conditions to find the value of d and k. Before I do that, notice that I could use any two hypothetical initial conditions that I wanted to, as long as the population is seen to double every 10 years. For example, I could use time t equals 10 and population, let's say 7. 10 years later, the time is now 20 and the population is now 14. So I could use this pair and I would get the same answer for d and k. But I'm going to pick 0, 1 and 10, 2 because those are very, very simple numbers to use. Let's start with this initial condition. When t equals 0, y equals 1. So that means I have d times e to the k times 0. So when t equals 0, y should equal 1. But this is just e to the 0 power, which is 1. So I have d is equal to 1. Substituting this back into the equation, now I have y equals 1, which I won't write, times e to the kt. Now let's use the second initial condition. When t is equal to 10, y should be 2. So that means I have e to the k times 10, and that should equal 2. I can get rid of this e by taking the natural log of both sides of the equation. Natural log and base e are inverse functions, so they cancel each other out. I'm left with 10k is equal to natural log of 2. Now I just divide both sides by 10. K equals natural log 2 divided by 10. Let's use the calculator to match this to a decimal answer. I'm getting 0.069. So the answer is A.